flatties and globe defenders, it's Critical Thing from Down Under, and in this video we're talking about the flaw of Flerspective. Now I know the flatties love to say that we don't understand perspective, but really what they're talking about is Flerspective, which is just this made up science, shall we call it pseudoscience, which is used to try and explain something that they cannot explain, like curvature. Well, they'll say that's not curvature, that's perspective. Really? Well, we'll see about that.
Here's a quick demonstration of the laws of perspective, which we must take into consideration with all observations that we make, including and especially those of ships in the distance which appear to have gone down below a horizon, usually attributed to being curvature of the Earth when it is in fact simply the laws of perspective at play. We can see from this example that even a small wave on the surface in front of us will block off a much taller and larger ship in the distance.
Whoa! What was that again?
Even a small wave on the surface in front of us will block off a much taller and larger ship in the distance.
So, a block directly in front of the camera can block off a mountain in the distance due to perspective. Okay. And therefore that means that a wave in the ocean in front of us can block off a big ship in the distance. Right. Seems to be a case of if she weighs the same as a duck, then she must be a witch. Now, in Phuket Word's deluded brain, these two scenarios are exactly the same. But let's take a critical look at the differences. So we have, in this case, the camera eye level is approximately there. In the ship photo, the camera eye level is approximately there. So, in the block instance, the block is in front of the camera is below the level of the block. In the ship picture, the camera is not below any of the waves. So if you are trying to equate a block to a wave in that picture, there's no comparison because there is no wave in front of the camera. The other thing is this block here is very, very close to the camera, less than 1 meter. Now, the waves in this picture, especially the ones that might be blocking the ship way out there, are 3 miles away, at least. Now, judging by the height of this camera, that's a lot more than 3 miles, but it's miles. Let's just say it's miles. So what is the difference between a few inches and a few miles? Well, according to Phuket Word, nothing. Absolutely nothing. Now, here's the thing. This block here is how big due to perspective? Pretty big compared to what's behind it, right? These waves out here are how big due to perspective? Tiny, right? So, a tiny wave cannot obscure a big ship. It's that simple. Now here's a diagram I drew which shows that if you're looking over the top of the waves, at least over the top, you could be higher, then the maximum that could be obscured of any ship is the height of the waves. So if the waves were 1 meter high, there would only ever be a maximum of 1 meter obscured for the ship, no matter how close the waves or how far away the ship was. The only way you can get more than that obscured is if you put your camera into the water so that the waves are higher than the camera, and I never do that. So we've got that picture, and then there's the other one that I've drawn about if you have a flat earth, there's nothing obstructing your view of the bottom of something. So you should always see the bottom, taking into account what we mentioned about waves, but in this case there are no waves, it's just a picture of a flat plane. And the only way you can see the things that we see by getting high, you can see further and more of an object, is if the surface is curved. That's the geometry that works in that situation. Now, I have been told that these diagrams that I draw do not take perspective into account. Now, here's the thing. They do take perspective into account, and I'll be showing more about that soon. And here is why. First of all, perspective never alters geometry. Perspective cannot make things disappear from the bottom up. Perspective cannot change the angles of things as they sit on the ground. The angles that change are the angles of incidence of the light to your eye. So in the example here I have, if your eye is looking at the ground below near your feet, then that angle is going to be a greater angle than if it is looking out in the distance. And this has the effect in your eye of perspective. Things in the distance will appear to rise, and that is because this angle from horizontal is small. So when you look down at your feet, you look down. When you look into the middle distance, you can see you would have to look up to see something in the middle distance. So this would appear to be higher, even though you can see that it is not, it is level, but to the eye it would appear to be higher. And so the further you go out into the distance, the higher that it would appear to be. But this is just a trick of optics. It has nothing to do with the geometry of the situation. It has nothing to do with what's obscured and what's not. Looking at this picture again with a screen placed at this point here near the eye, you would see if that was a projection screen, so the scene behind it was projected onto that screen. You can see that this point at the bottom of this square block over here would appear on the screen as that highest point there. And this middle distance point would appear there, and down at near your feet it would appear there. So that's what, on that screen, the far point would be higher than the low point, and that's the effect of perspective. Perspective just is like making a projection onto a 2D view from a 3D view. And it does not change the fact that something in the distance is still at ground level. It does not change the fact of the geometry of the situation. So, as a little bit of a comparison, I've got a flat surface there at the top, same diagram as before, and a curved surface in the diagram below, which the curve gradually curves away. It's not to scale. The curve curves away from the observer, as would happen on the globe, Earth, and the perspective is still in force. So until you cannot see over the curve, things would start to rise. And this is not a hump, this is just perspective. And so if you did have some waves on the ocean, for example, they could restrict the view, the bottom of the ship, or whatever else was over here, hidden under the curve, whereas in the top view, the things, if you're looking over the top of the waves, you're going to see the bottom of the ship or whatever building on the shore or whatever, you're going to see it. But on a curved surface, this eye level is still above the waves, but there is still some part obscured in the distance. And the perspective remains the same. The further away items, things are appearing higher in your view. Perspective doesn't change whether it's flat or curved. Some people like to say that when the surface curves away from you, there's a hump in the middle, but that's just not the case. I've done a little bit of a model in Blender. Now, I'm not very proficient at Blender, I get by. I've modeled the block scenario like Phuket had it in his video, and I have a perspective camera there, which and another block which is a dimension of roughly 1, and behind it is a bigger block of dimension roughly 4. So you can see that these blocks are on a flat surface, and when I switch to the perspective camera, you can see that the surface rises in front of the camera, just as everybody knows it does, due to perspective. But the thing is, the surface, it doesn't actually rise, it's still flat. Now, this is an important thing. I know it sounds obvious, but there have been a large number of times when people do not equate a perspective view with the surface not changing its geometry. The geometry doesn't change, it's still flat there, but in perspective it appears to be rising. The other thing about this is you can see that the small block completely obscures what's behind it, and that is because the camera is in front of the block. Now, if we move the camera so that it is above the block, just like a camera above the waves, and you can see that what's behind it becomes visible. So something small in the foreground is no longer obscuring something in the background. Now, if you've got your camera right at the top of the block there, okay, there is a maximum of 1 unit there, let's call it 1 meter, being obscured. If you've got the camera at the level of the top of the front block or above, maximum of 1 meter obscured on the block behind. And as you raise the camera, you can see even the bottom of the second block. So a small wave on the ocean in front of us has zero effect on the obscuring of a ship in the distance, as you can see if your camera is sufficiently high. And even that you can see the ship in the distance even with that big block there, if we raise the camera high enough here. So I've changed to a rendered view, and this is again a model of flat plane, just so that we can all see what it might look like if there was such a thing as a flat plane for a very long distance. Now, flatties say the higher you get, the further you can see, and that's explained because of this. Of course you can see further here, but that's not exactly the same. Blockage and angular resolution is not exactly the same. You know, if I move the camera down, the checkers in the distance are nearly closer together. They're still there in the view, but you cannot make them out because of angular resolution. And as you raise the camera, you can see more checkers because you're changing the angular size by getting a different angle of attack, shall we say. So on a flat plane, nothing actually comes out of view. So it's not hidden by an obstruction. Perspective doesn't do that. It's there, but you may not see it because it's too small. That's what perspective does, makes it small. But then you can zoom in. You can zoom in and see something. So we can go up. I can zoom in, and zoom in changes the perspective because it makes something bigger. But it doesn't change the obscuring of something. Perspective can't do that. Only an obstruction can do that. So, as you can see, if I come down, there's part of my ship obstructed there, and then I zoom in. The amount of ship obstructed doesn't change simply because I zoom. It's obstructed by that block, and that doesn't change. I can zoom in and I still cannot see the bottom of the ship. So if I rise above that obstruction, and you can make an analogy with the curve of the earth, you rise above the curve of the earth, then you can see the bottom. Perspective doesn't do that. That's just a change in the camera height behind or in front of the obstruction. So if your camera is not behind or in front of, depending on which way you look at it, is not, see this block here, if this camera is not in front of the wave and less than the height of the wave, then the ship is not going to be obscured. If I'm looking over the waves or whatever, I can see all the ship. If I'm down below the height of the waves, that's when it will be obstructed. And that's what makes the big difference.